So welcome to this lesson. We are dealing with common logs. It's a topic in Form 2 after indices part. So we consider 10 power 0, which is equals to 1, 10 power 1 is equals to 10, 10 power 2, 100, 10 power 3, 1000, 10 power 4, 10,000. The indices 0, 1, 2, 3, 4, as they are listed here, are called the logarithms of corresponding numbers to base 10. So we can say if we have 10 power 2 as an expression, this will be equal to 100. And therefore, we can write this one as log to its base, and we get what the answer will be. So this one we call it the index form of a number or index notation. Then we can also write this index notation to log form, and this log form will be equal to log of 100 to its base. So remember, this is the number. We have 2 as the power or the index or the exponent, and 10 as the base. So if we take log 100 to its base, should be equal to the logarithm. So this is what we call the logarithm of 100 to base 10. So this form of writing this way, we call this one the logarithmic form or notation. So we can change from index to log form. So write in logarithmic form, we have 4 power 2 is equals to 16. So we say log of the number, our number is 16. The base is normally written down here, is equals to 2. And also log 27 is the number to base 3, is equals to 3. So here our number is 0.01. So this will be log 0.001 to base 10 is equals to negative 3. And also if we have 4 power a half, this is the same as log 4 to its log 2. 2 will be our number. Log 2 to base 4 should be equal to a half. So this side we have the logarithm form, and this side we have the index form. So we can write from one side to the other, but our interest here is logs, and we are going to deal with logs. And for this purpose of this topic, we are going to deal with logs to base 10. So consider a number like 5.8. This number 5.8 can be written in standard form as 5.8 times 10 power 0. And if we do that, we shall have the logarithm of this number, which we are going to raise to this power, log of 5.8. Remember, we use the 4-figure mathematical table to find the common logs. So to base 10, the table gives us to base 10. So we have the logarithms given to base 10, and when we are doing logarithms, we have log of x to base 10. So these numbers are given to base 10. So we have the numbers, and you can see here we have a column called x column. The x column requires us to write the number in standard form so that we can easily get the numbers. And also we have the main difference here, which is for addition. So when we read the numbers, we'll see how to get the log. So log of 5.8 is a number 5.8. Since it is 5.8, we are going to have it as 5.8, and then we only read the 0 column. And 5.80, we are going to get 0.7634. So 5.8, then we read at the 0 column, so we have 0.7634. So which we say it's 0.10 power 0.7634. And since we had said initially that a power m multiplied by a power n, we add the powers, then this would be 10. We add the 2, this is 0 and this is the other 0 point, so 0.7634. So the logarithm of 5.8 to base 10 will be given by 0.7634. So if we consider now a number like 58, so 58 in power form is 5.8 standard form times 10 power 1. This would be 10 power 0.7634 times 10 power 1. So we add the powers, we get 1.7634. Therefore, the logarithm of 58 base 10 will be equal to 1.7634. To our next example, we have 5,800, and this can be written as 5.8 times 10 power 3. This is power 3, and therefore we have 10 power 0.7634, and then 10 power 3. So same basis, we add, we are going to get 3.7634. Therefore, the logarithm of 5,800 to base 10 will be equal to 3.7634. So the decimal part, this decimal part, you're seeing 0.734, we call it the mantissa, and the integer part, the whole number part, we call it the characteristic. So how do we read logarithms from tables? So we have our mathematical table, which is given to log of numbers to base 10. So here, if numbers are from 0 to 1 to 10, then we can read directly from the mathematical table. And if numbers are less than or greater than 10, we first write the number in standard form as a times 10 power n, where n is the integer part, which you have called the characteristic. So we are going to take examples to see how to get or how to use mathematical table to read logarithms. So read the logarithms of the numbers. So the first number is 12.3. So we'll have to write this one in standard form. So this will be 1.23 times 10 power 1. So we are going to go to the column of 1.2 on our mathematical table. Logarithm part, we have 1.2, then we did 3, 1.2, 1.2, you can use your ruler clearly here, and we are going to get at 1.2 and then 3, where we intersect, we are going to get this number here, which is 0.8 0.0899. So we are going to take the positive parts for 1.0899, and that is the logarithm of that number. The next number is 431.5. So standard form, and the standard form of this one is 4.315 times 10 power 2, which is going to give us 2 points. Then we read from the table 4.31, and 4.31, we can see it is 0 point. That number will give us 6345. So we have 0.6345. Then we go to the main difference column, the column that says add. We read 5. At 5, we are going to get a number here. If you come from 5, from top 5, we are going to get the number is 5. So you read 5. This 5 should be added to this value here, and we add it towards the end, or you can say 0.005. This will give us 10. And we have 5, 3, 6, 0. So this is what we get from the table. So the logarithm of 431.5 to base 10 will be given by 2 points. We add this, we get 6350. The next number is 7,924. So in standard form, this number will be 7.924 times 10 power 3, and this will be 3 points. So 7.9 7.924. So we go for 7.92. We are getting 0.8987, 0.8987. Then we go to the main difference column for 7.924, and we are going to see at 4 we have 2. So we add the 0.002, or we just add towards the end of this, and this will give us 0.8989. So this is the log of this one, so the powers will be 3.8989. Then we have a number here, 958,312. So we write this one in standard form. We get 9.58312 times 10 power 1, 2, 3, 4, 5. So this will be 5 points. So our mathematical table is called 4 figure. So 4 figure, we need to express this one to 4 significant figures. So 1, 2, 3, 4. So we are going to have this one as 9.583 times 10 power 5. Then we read the logarithm of 9.583 from the mathematical table. So 9.58, 9.58, 8 is the second last, so we have 9.8 9.58 so we are going to have 0.9814. Then we move to the next column. The next column is 3, and from here we can see 3 is going to give us 1. So we add 1. So this will give us 0.9815, and then this is for this number. So we add, so adding to 5, we are going to get 5.9815, and that's the log of 9.583. So that's how we read logs of numbers which are more than 1. So what do we do with the numbers which are less than 1? So numbers less than 1 are given here. So we have, for example, 0.034. This number we just write in standard form, and therefore we are moving towards write 1, 2. So this number will be 3.4 times 10 power negative 2. In logs, we write this one as bar 2. Remember, this one will be a negative number, but its log will give us a positive number. So I'm sure now you have seen how we read this log. So we go to 3.4. So at 3.4 we have 0.5315. So 0.5315, and that will give us the logarithm of 0.034. The next number we have is 0.3814. So we write this one as 3.814 multiplied by 10 power. This decimal moves 1 step, so -1. So this will be bar 1 point. So again 3.814. So 3.81. Then we go to where 4 is. So 4 will give us 4. So we add 4 to this, we get 5813, and that one gives us the log of that number. So we also have this, so we have to move 1, 2, 3. So this will give us 9.47 times 10 power -3, and this will give me bar 3.947. 994 gives me 0.947 will give us 0.9763. 9763. And now I'm sure we can find the two. Try out the two numbers. 0. Write them in standard form and then read the values. And make sure you have the bars and the decimal part. So to the next part, we are going to see how do we go back to the number, and how to go back to the number after getting the logarithm. We call it anti-logarithms, and this one is from tables. So we reverse the finding of logarithms. So we consider a number whose logarithm is 0.6107. So that number 10 power 0.6107. So we go to the anti-logarithms. In this mathematical table, there is part after logarithms we have anti-logarithms. You can see it's 10 power x. So we need to know what number was this x. So we go back and find. So for this one, you're going to see we have 0.00 on the x, 0.101.02. So we are going to have 2 digits, then we read the other. So in our case, we have 0.61. So we go to where we have 61. So the next page. So at 610, 610, we will have 0 point. We have 4.074. Then we go to the column 7, and here where we have 7, we are going to add this 7 that comes from above, we lead, and where we intersect with the 6.1, and we move down the line, the point we are getting here. If you move down this way, you will get 7. So we add this 7. So after adding the 7, we get so the number that logarithm is 0.6107 is 4.081. So this one takes us back to the number. So consider bar 1.3238, and this is the same as 10 power negative 1 times this number which we call 10 power x. So we find the logarithm of the anti-logarithm of this one to give us the number, then we multiply it by 10 power negative 1. So from our mathematical table, the anti-logarithm of 3.286, 3.28, you find it is 2.128. Then we have 6, and 6 we get it from this column of 6, we get 3. So we add 3 to this, so we get 2.131 multiplied by 10 power negative 1, and therefore our number was 0.2131. And finally, we have bar 4.7606 is equals to 10 power negative 4. Then this is what we need to read from the anti-logarithm. Then we get the number multiplied by 10 power negative 4. So we have 7.660 will give us 5.754. 760. Then we go to 6. So you follow that column to where you have 6, and our 6 reads 8. So we add 8, and we are going to have 5.762 times 10 power negative 4. So this number was 0.0005762. That is the number whose logarithm was bar 4.7606. So that's how we find logarithms to take us back to the number. So let's see operation of numbers or with logs. How do we work with logs? Logs can be added, they can be subtracted like any other number. For example, we have we add in 2.690 plus 2.5999. So what we do, you can decide to write this one in vertical form 2.6590. You add to 2.5999. This will give us 9, 18, 15, 12, 5 points. So we can add logarithms that way. We can also add one with a bar. So this is bar 2.46 added to 4.89, and therefore we add the 2, we get 15. This is going to give us 13. Then we carry 1. 1 minus 2 plus 4. We are going to get 3. So this will be 3.35. Next we have 2.3271 plus 1.685. So you shall just apply this one as we have done in part 1. So let's look at part 4, which has bar 3.416 plus 0.71 minus bar 2.058. So this one we can add first. Bar 3.416 add to 0.713, 9 to 11. This will be 1 plus bar 3 give us bar 2. So that is bar 2.129. Then we subtract the results, we subtract this one. So we have bar 2.129 minus bar 2.058. So this is 1, 12, this will give us 7, 0. Then we have bar 2 minus 2 give us 0. So that will give us 0 point. Finally, with the addition and subtraction, so this is bar 3.7894 minus bar 1.3056. So if we subtract this one, we have 14 minus, we have 8, we have 3, we have 8, 4. Then we'll have bar 3, which is minus 3, minus 1, which give us positive. So this will be bar 2 point. So with this one, we can do that for addition and subtraction. So writing it in column form is better than work one by one as you add. The next thing is how do we multiply with, or how do we multiply logs. So a log can be multiplied, and I'm going to use these examples. So bar 2 multiply 0.6538 multiplied by 3. So you can decide to have it as this, bar 2.6538. This is going to give you 24. Carry 2, you get 11. Carry 1, you get 16. Carry 1, 19. Carry 1. So if we get 1, this is going to be 6. So bar 6 plus 1 will give us bar 5. That is one way. You can also separate this one as bar 2 plus 0.6538, then you multiply by 3. So multiplying each by 3, you get bar 6 plus 0.6538 times 3 will give us 1.9614. And when we add the powers, you can see they're going to give us bar 5.9614. So you can use either, you get the same results. The next one is bar 1.8935 times 2. Bar 1.98935 times 2. So this will give us 10, carry 1, have 7, 18, we have 17 bar 1, and we have bar 1 points. So you can also try bar 1 plus 0.8935, then you multiply by 2, this will give us bar 2 plus this will give us 1.1.787. So when add these two, you get bar 1.787. So either method can be used. So we can also divide logs, and while dividing logs, like the first one, we have 2.9504 divided by 2. So this one we can directly divide by 2.9504. Here you can even use your calculator, and this is going to give us 1.4752. When we have this bar 2, this one now requires us to separate bar 2 divided by 2 plus 0.9504 divided by 2. So when I divide this one, I'll get bar 1 plus 0.9504 divided by 2. This will give me 0.4752, and I can add these two to give me bar 1.4752. Our next case, we have bar 2.7910 divided by 3. So this is bar 2 divided by 3 plus 0.7910 divided by 3. So when we divide bar 2 by 3, then this one will not work out. We want to make this number bar 2 divisible by 3 by having the next least negative number. So if, for example, I need the next number that is divisible by 3 will be negative 3. So I have to subtract 1 to this. So I'll get negative 3 and then add 1. Negative 1 plus 1, which is 0, which allows us to rewrite the equation, the expression in a different way without changing it. So I'll have bar 3, which I've said is negative 1 plus 1. Negative 1 plus 1 is 0. So the effect on this is 0. So we just rewrite without changing the equation. So this will give me bar 1 plus this is 1.791 divided by 3, and this will give me 0.597. Adding this, we get bar 1.597. So it's good to note when these two, especially when it is negative and it is not dividing, it is good to know what should be done. Make it divisible by getting another number which is going to be divisible. So when you subtract 1, for example, you add 1. If you were to subtract 2, you add 2. For example, if this number was to be divided by 5, so by 2.7910 divided by 5. So again here we'll have by 2 over 5 plus 0.7910 divided by 5. This number is not divisible by 5. We make it divisible by 5 by subtracting 3. So we're going to have negative 5 over 5. That 3 should be added to this, so we get 3.7910. Then we divide by 5. This gives us bar 1 point, and then we have 3.7910 divided by 5. This is going to give us 0 plus 0.7582. Then the answer will be bar 1.7582. So it is good to know what to do for you to make sure these numbers are divisible. Otherwise, that's how we divide. We are going to continue with more examples. as we proceed so that you can see the application. So welcome to this part. We are going to deal with logarithm tables to evaluate multiplication. So use logarithm tables to evaluate 75.26 multiplied by 0.0234. So in this case, it's good to organize somebody's work, and you organize your work this way. As you have seen, we are writing standard form and then reading the logarithms. So the first thing is to have the number here. Then you have the standard form, and then you will have logarithms from the table. Then we have this number as 75.26, and we have 0.30234. So 7.526 times 10 power 1, and this is going to give us 2.34 times 10 power negative 2. This becomes bar 2 points, and this is 1 point for logarithms. Then we go to the tables. We are going to read 7.5, 7.526, so 7.52 give us 0.86762. Then we add 2 at the column at column 6 we have 4, so we are going to have 0.8766. So the logarithm of 7.526 is going to be 1.8766. Then we have the log of 2.34. So 2.34, we get 0.3692. And since these numbers are multiplied, we are going to add the logs. So we add these logs. So this gives us 8. Then we get 15, color 1, 14, color 1, we get 12, color 1. So 1 plus 1 we get 2, minus 2 we get 0. So once we get this number, we get the antilog, so that we go back to the number, because the logarithm of the two has been added, and we add them because we have the said and the powers are the same. We also add the bases are the same, we add the power. So the antilog of 0.2458 at 2.245 we get 1.758. Then you add to the number that intersects at column 8 at 25, which is 3. So we are going to have 11, 6, 7, 1 point. So it will be 1.761. So when you multiply this one by 10 power 0, we get 1.761 as the answer. So let's see what happens when we are dividing. So the first thing, then we organize, we say the number, the standard form, so we have 16.08 and we have 276.3. So 1.608 times 10 power 1, and that will give us 1 point. 2.763 times 10 power 2, 2 point. So when we read this one from the table, 1.60, 1.60 will give us 0.2041. Then we add 2, value at 8, it gives us 21, so 0.2062. So the log of 16.08 will give us 1.2062. Then we have 22.763. So 2.76 will give us 0.4409, and then at 3 we are having 5. So we add 5, we get 0.4414. Then we have 2.4414. These numbers are divided, so we subtract their logs. So this will give us 12 to give us 8. 5 minus 1 we get 4. 10 we get 6, and this is 1 minus 6, which are supposed to have 7 here. This is 0, we get bar 2. So this will be 10 power negative 2 times 0.76 0.7648. Make sure you go to the anterow, don't confuse. 0.7648. This is giving us 5.808. Then at 8 we are getting 10. So you add 10, you get 5.818. So 5.818 times 10 power negative 2. So our answer will be 0.05818. So which is the required answer. So we can keep on working with this. So let's look at more examples. So let's continue. We have 3.142 multiplied by 2.718 divided by 6.49 times 81.2. So again we can organize this one as number standard form logs. So 3.142, 2.718, 6.49, 81.2. And writing them in standard form, we have 3.142 times 10 power 0, 0.2.718 times 10 power 0, we get 0.6.49 times 10 power 0, and 8.12 times 10 power 1. So when we read from the tables, 3.142, we get 0.4972, then 2.18, we get 4343. When we add these two, we get 5, we get 1390 point. So this for the numerator. So we also work for 6.49, and 6.49 is 8122, 1.82, we get 8.12, we get 9096. Since the numbers again are multiplied, we add these two. So after adding this, we are getting 8, 1, 2, 7, 2 point. So this is the denominator after adding logs, numerator after adding logs. So numerator divided by denominator, we are going to subtract the logs. So we write this one as 0.9315 minus 2.7218. So when we subtract this one, we are getting 790. Then we have 2 and have bar 2 point. So we use this one and did the anti-logarithm by 2.2097. So this will be 10 power negative 2 times bar 2, 2.20.97. which will give 1.621 multiplied by 10 power negative 2, we get 0.01621, and that is us for that. So we now have the square root. We have the same question and the square root, so we'll carry out the same procedure until a point where we reach to this, because the square root is for everything. So we are going to have so if I can list this one quickly, the same procedure, number, standard form, log. So 3.142, 2.718, 6.49, 81.2. So I can just copy because the same question, the only thing has changed the square root, and I want to reach where the square root is 3.142 times 10 power 0. So 0.4972, 2.718 times 10 power 0, 0.4343 after addition, 0.9315, and you have 6.49 times 10 power 0, 8.12 times 10 power 1, 0.8122, 1.9096, and after addition we got 2.7218. So we also subtracted this one, and from the logs we are able to get this one as 2.2097. So instead of reading this one, we have the square root. The square root is the same as power a half, so we multiply this one by a half, which is the same as bar 2.2097 over 2. So since this number is divisible by 2, we are going to have it as bar 1 point. So if we divide this one, 0.097 divided by 2, we get 1.1049. And if we work out this anti-logarithm, 10 power negative 1 times 1049, we get 1.274. Therefore, the number would be 0.1274. That's the solution for that question. Then we move on to the next example. So in this example we have 0.6493 power 2 multiplied by 0.91229215, and then that product is raised power a third. So we can work out this one, and this one we can do it number standard form logs. So 0.6492 squared, so 6.492 times 10 power 31, so by 1.8124, and this one we multiply by 2. So when we multiply by 2, we are getting 8, 4, 2, 6, and then by 1 point. Then we shall add this one too, because this multiplication, we shall add to 0.9215. This is 9.215 times 10 power -1. So add to by 1 point. The log of 9215 will give us about 1.9645. Then these two numbers are multiplied, we are going to add, and this will give us 3985 by 1 point. And we are supposed to raise this one power a third. So power third is the same as multiplied by 1/3. So by 1.5893 divided by 3. So this one, we are writing this one as by 1/3 plus 0.5893 over 3. And this we say now, we make this one divisible by 3 by subtracting 2. So we got by 3/3 plus the 2 is subtracted here, we add 2.5893 over 3. So this will give us by 1 plus 0 point. So we can divide this one, 2.5893 divided by 3, and we get 0.8631. So this would be by 1.8631. And this one now, we can leave the antilog as 10 power -1 times the antilog of 8631. And our mathematical table, we get 7.296, and the answer will be 0.7296. That's how we use logs to find that one. So when you square, you multiply by 2. When you're getting the cube roots, we divide by 3. So the solution, that one can easily be followed, and we get the answer as 0.9296. Next, we have the fourth root of 0.8932 squared times 582.3 power third divided by 69.35 power half. So we organize this one, number standard form log. So our number is 0.8932. 8.932 times 10 power negative 1 is by 1.89. That 2 will give us 9510. We multiply this one by 2 because this one is squared. We get 0, 2, 0 again, 9 but by 1. Then we get 582.3 times, which is 5.823 times 10 power 2. So we get 2.7651. We are supposed to divide this one by 3. And since this is positive, dividing by 3 is easier. 2.7651 divided by 3, we get, after division we get 0.9217. Since they are multiplied, we are supposed to add this and this for the numerator. So we have 1.9020 added to 0.9217, and that sum is going to give us 7328 point. So this is for the numerator. For the denominator, we have 69.35. So 6.935 times 10 power 1, which is 1 point. Taking this one, we get 8410. And we are supposed to place power half, so this means divide by 2. So since it's positive, we can just divide directly by the calculator. Both the mantis and the characteristic is positive, so we can just divide and get 0.9205. So this is what we get in the denominator, and this is what we have for the numerator. So we subtract the 2. So we have 0.8237, the numerator, subtract 0.9205, which we get, this will give us 230, this will give us 9, and this by 1 point. We are supposed to get the cube, the fourth root of this, so we are going to have 1.9032 divided by 4. So this is the same as by 1 over 4 plus 0.9032 over 4. To make this one divisible by 4, we subtract 3. So by 4 over 4 plus 3.9032 over 4. So by 1 point, so 3.9032 divided by 4, we get 9758. So 0.9758. So this is by 1.9758. Read the antral, which is 10 power negative 1 times the antral of 9758. You will get 9.459 times 10 power negative 1. So their answer would be 0.9459. So thank you for watching. Let's keep learning maths. More and more examples can be done. I hope you have also learned something. Welcome.